What if I told you a humanoid robot now walks with over 90% human accuracy? Another one is training Kung Fu with real Shaolin monks. And a third robot just landed a toe-balanced backflip that even elite gymnasts would struggle to perform. This is not science fiction. This is 2026 robotics. In today's video, I'll show you 3 of the most insane humanoid robot breakthroughs ever recorded, and how together they reveal just how close we actually are to human-level machines. Let's start with the one that looks almost too human. Meet Moya, a humanoid robot developed by Chinese robotics company DroidUp. At first glance, it doesn't even look like a robot. It makes eye contact. It shows subtle facial micro-expressions. It maintains natural posture. And most disturbingly, it walks like a real human. Its walking motion isn't stiff or mechanical. Instead, it shows smooth weight transfer, heel-to-toe stepping, and natural body sway, just like a real person. Even small details like shoulder movement and hip rotation closely match human biomechanics. According to DroidUp, Moya achieves about 92% human walking accuracy, making it one of the most biomechanically realistic humanoid robots ever built. But this isn't just about walking. Moya maintains a human-like body temperature between 32 and 36 degrees Celsius, allowing it to feel warm during interaction. This isn't a technical requirement. It's a psychological design choice meant to make humans feel more comfortable and emotionally connected during communication. When people interact with cold metallic machines, their brains immediately classify them as tools. Warmth changes that perception. It subconsciously signals life, safety, and familiarity. This tiny design choice dramatically improves human acceptance and trust. Its facial system can reproduce tiny micro-expressions, including subtle eyebrow movement, blinking patterns, lip motion, and eye focus, creating emotional realism rarely seen outside of high-end CGI. These micro-expressions allow Moya to display curiosity, attention, agreement, confusion, and emotional response, which makes interactions feel far more natural and intuitive. Its entire architecture is built around embodied AI, meaning the robot doesn't just calculate movement. It physically understands space, balance, posture, and motion in a way similar to biological systems. Instead of simply executing pre-programmed actions, Moya continuously senses its environment, predicts outcomes, and adjusts its movements in real time. This allows it to navigate crowded spaces, avoid collisions, maintain stability, and respond smoothly to human presence. Standing around 1.65 meters tall and weighing just 32 kilograms, Moya has near-human proportions, enabling natural gait, smooth turning, and realistic weight shifting. But why does all of this matter? Because real-world integration requires something far deeper than just movement. Hospitals, schools, elder care, customer service. These environments demand natural interaction, emotional awareness, and social comfort, not mechanical motion. And that's exactly where Moya is designed to operate. Its creators say Moya is built specifically for delicate human-centered environments, where emotional realism and comfort matter just as much as physical capability. This is social robotics, and it pushes us straight into what scientists call the uncanny threshold, the point where machines begin to feel almost alive. But emotional realism is only one side of humanoid intelligence. What about physical mastery? That's where our second robot enters. In one of the most surreal scenes ever recorded, Agibot's humanoid robots were filmed training Kung Fu alongside real Shaolin monks, inside the legendary Shaolin temple itself. Yes, robots practicing martial arts with monks. In the viral footage, Agibot's humanoids replicate complex Kung Fu sequences, mirroring precise stance shifts, hand strikes, foot placements, and dynamic balance transitions. These movements require precise timing, full-body coordination, flexible joints, rapid center of mass adjustment, and constant balance correction. And this isn't choreography. This is real-time, embodied learning. Agibot's humanoids use advanced perception systems, dynamic motion planning, and adaptive control algorithms to copy and refine martial arts techniques, movements that demand millisecond-level coordination across the entire body. Every strike, block, step, and turn is analyzed, adjusted, and optimized in real time. Kung Fu is not just movement. It is balance under chaos. It involves explosive motion, sudden stops, rapid direction changes, and unstable stances, all of which are extremely difficult for machines. And that's exactly why this demo matters. And when robots master Kung Fu, it means they're learning agility, reaction speed, full body coordination, and adaptive balance. These are the same abilities required for real-world navigation, disaster response, construction work, and physical assistance tasks. Which brings us directly to the most insane demonstration of all. Boston Dynamics' Electric Atlas has already stunned the world with parkour, sprinting, and acrobatics. But this newest demo is on another level. In a recent clip, Atlas performs a powerful backflip and lands directly on its toes, a maneuver that requires extreme balance control, precise torque modulation, and perfect timing. Human gymnasts spend years training to safely land toe-based flips. Atlas executes it algorithmically. Boston Dynamics engineers explain that these flips push nearly every joint on the robot to its mechanical limit, requiring real-time adaptive control and ultra-precise stabilization. This is not pre-scripted animation. The robot calculates force distribution, joint angles, angular momentum, and landing absorption in real time, adjusting its motion in milliseconds as conditions change. And here's the truly insane part. For robots, landing is actually harder than jumping. Jumping requires power. Landing requires control. All that energy must be absorbed without destabilizing the center of mass or losing balance. Toe landing shrinks the contact surface to a tiny area, forcing ultra-fine balance correction in milliseconds. Even a small miscalculation can cause a catastrophic fall. Early tests reportedly caused Atlas to tangle itself mid-air repeatedly, showing just how complex this maneuver truly is. This is not a trick. This is a balance control breakthrough. And balance is the foundation of real-world mobility. Now connect all three breakthroughs. Moya shows human realism and emotional intelligence. Agibot demonstrates dynamic martial movement and adaptive coordination. Atlas reveals extreme balance, agility, and biomechanical precision. Together, they reveal something profound. We are no longer building robots that simply move. We are building robots that embody intelligence. Machines that understand space, motion, emotion, and physical interaction, all at once. This is the shift from mechanical tools to autonomous physical agents. The humanoid age is no longer coming. It is already here. And this is only the beginning. If you want deep, real engineering breakdowns of humanoid robots, not hype, not marketing, just pure cutting-edge robotics, then make sure to subscribe to RoboFrontier.